Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two problems using the concepts of derivatives. So as per the first problem, determine the slope of the tangent to the curve y equals cos 2x at point pi over 6 comma 1 over 2. So we have to find the slope of the tangent to this curve y equals cos 2x. So we know that the slope of the tangent is equal to the value of the first derivative of the function at the point at which the tangent touches the curve. So the first step is to find the derivative of this function. Y prime equals, now this cos function is a composite function. So there's an outer function cos and the inner function is this polynomial function 2x. So we have to use chain rule to find the derivative of this function. So as per the chain rule, we start with the derivative of the outer function and the derivative of cos is minus sine. So we get times the derivative of the inner function and the derivative of 2x is 2 times 1. Now we can simplify this expression. So 2 times 1 is 2 and 2 times sine 2x or negative sine 2x will become negative 2 sine 2x. Now we have to find the slope of the tangent at the point pi over 6, 1 over 2. So in order to find the value of the slope, we should sub in x as pi over 6 in this derivative. So m, which represents the slope, is equal to now we have to simplify this expression. Now 2 times pi over 6 is 2 pi over 6. Which can be reduced to pi over 3. And sine pi over 3 is equal to square root of 3 over 2. And we can cancel out the 2's. So this is the value of the slope of the tangent to this curve at point pi over 6 comma 1 over 2. So we are done with the first problem. Now we can analyze the second problem. So as per the second problem, if y equals a cos k times t plus b sine k times t, where a, b and k are constants, show that the second derivative of y plus k squared y equals 0. So in this problem, we have to prove that the expression on the left side becomes equal to 0. So the first step is to find the second derivative of y, and for that we'll have to find the first derivative. So let's start with the first derivative of this given y equation. So y prime equals, so in the first term a is the coefficient of the term, so it will stay as it is. Now for cos kt, we'll have to use chain rule because there is an outer function cos and the inner function is the polynomial function kt. So the derivative of the outer function cos is negative sine. Times the derivative of the inner function, and the derivative of kt will be k times 1 plus Now in the second term, b is the coefficient, so it will stay as it is. And we'll have to use chain rule to find the derivative of sine kt. And sine is the outer function, so its derivative is cos times the derivative of the inner function kt, which is k times 1. Now we can simplify this expression. So in the first part, we can multiply k times 1, which is k, and then we can multiply k by a, and which is ka, and times minus sine kt will be minus ka sine kt. And in the second part, we can multiply k by 1, which is k, and then k times b will be kb. Now we can find the second derivative of y by finding the derivative of this derivative. So in the first term, negative ka is the coefficient of the term, so it will stay as it is. And for sine kt, we'll have to use chain rule to find the derivative. And the derivative of the outer function sine is cos times the derivative of the inner function kt, and the derivative is k times 1 plus, now in the second term, kb is the coefficient of the term, so it will stay as it is. And the derivative of cos kt will be the derivative of the outer function, and the outer function is cos, so the derivative is minus sine kt. Times the derivative of the inner function kt, which will be k times 1. Now we can simplify this expression. So in the first part, k times 1 is k, and we can multiply the k by ka, which will become negative k square a times cos kt. And then in the second part, k times 1 is k, and k times kb will be k square b. And when we multiply it by the negative sign term, the whole term will become negative. So this is the expression for the second derivative of y. Now we can find the expression for k square y. So for that, we just have to multiply k square by the expression for y. So we'll substitute y with a cos kt plus b sin kt, because that's the given expression for y. Now we can simplify this expression by distributing k square into the parentheses. So we get so this is the expression we get for k square y. Now we can sub in these expressions for the second derivative of y and k square y in the given statement that we have to prove. So this is the statement we have to prove. So we know the second derivative for y is equal to plus, now for k square y, we got the expression now on the left side, k square a cos kt and negative k square a cos kt cancel each other out. And then negative k square b sine kt and then positive k square b sine kt cancel each other out because they're like terms. So we are left with 0 equals 0. So that means the left side is equal to the right side. So we have proved that the statement that the second derivative of y plus k squared y is equal to 0. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.